Hey everybody, my name is Chris, and I'm a tutor here at Chegg.com, and I mostly do math and a little bit of computer science. And in this video, we're going to talk about nonlinear equations and do an example of solving one. So when we talk about linear equations, maybe something like 2x minus 3y equals 4 and x plus 6y equals 10, we have a bunch of techniques that we could use to solve systems like this, and they're pretty straightforward. And depending on how the system actually is, the techniques might not really even be that bad to do. So unfortunately for nonlinear systems, it isn't really the case that we have techniques that will work in general for all types of systems. But for very specific types of nonlinear systems, we can try some techniques, some tips or tricks. And actually even some of the same techniques that work for linear systems, we might be able to apply to nonlinear systems. So let's see what's going on with this system here. So we have x squared plus y squared equals 18, and x times y equals negative 9. So this system is very nonlinear because we have the x squared and the y squared. We got x's being multiplied by y's. So this is not linear at all. But what we can do is try a trick that we can also use for linear systems. So what I want to do is multiply the second equation, both sides of that, by 2. Alright, so then if I rewrite the system, then we're still going to have x squared plus y squared equals 18, but then the second equation has now become 2xy equals negative 18. Alright, so we have this system of two equations here, and now notice what happens if we add these two together. Well, if we add these two equations together, we get x squared plus y squared plus 2xy equals 18 minus 18, which is 0. Okay, so we have that. So, well, that's nice. Now, what about this? Let's rewrite this ever so slightly as x squared plus 2xy plus y squared. Then we have equals 0 still. So does this look like something that maybe we could factor? And yeah, it is something we can factor. We can actually factor that as x plus y quantity squared, and we still have equals 0. Now, if you're not convinced of that, let me come off to page 2, actually, and then say x squared plus 2xy plus y squared equals x plus y quantity squared. So this is what we want to show. Now it's actually easier to go from this side to this side. So let's expand on the right hand side. So x plus y times x plus y, if we FOIL that, remember what we want to do is FOIL, we're going to get x squared, and then the outer gives us x times y, and the inner gives us y times x, which is the same thing as x times y. And then last gives us y squared. So notice that this is just x squared plus 2xy, okay, and then plus a y squared. So that's all that's happening there. All right, and that shows that x squared plus 2xy plus y squared is actually the same thing as x plus y quantity squared. So if x plus y quantity squared is 0, we can take the square root of both sides and just get x plus y equals 0. Well, hey, what that means is that x equals negative y. So actually get rid of that. So that tells me that x has to equal negative y. Alright, so I'll put a little fluffy cloud around that because that's important, but it's not quite our final answer. So x equals negative y. Well, let me take that and stick that back into either one of these equations. I think I'm going to want to use maybe this equation here. So remember we had xy equals negative 9, and we just found out that x equals negative y. Alright, that's what we just concluded. Well, if x equals negative y, let's go ahead and stick that into here. So I'm going to stick this into here. Now, if x is negative y, then what I'm actually going to get is negative y times y equals negative 9. Okay, because remember, x is negative y, so this used to be x, now it's negative y. Okay, so negative y times y is just negative y squared. So we have negative y squared equals negative 9. Divide both sides or multiply both sides by the negative 1, we get y squared equals 9, and then take the square root of both sides, and then we're going to get y equals, now we have to be very careful here, plus or minus 3. Okay, we get y equals plus or minus 3. So we have two values of y that satisfy that equation, and we could use this to get two corresponding values of x. So if y equals 3, then x equals negative 3 because x is negative y, okay? And also if y equals negative 3, because remember y could be plus or minus 3, okay, y is plus or minus 3, and if y is minus 3, then x is negative 3, which is just positive 3. Okay, so then we have that. So that's those are the only two solutions to this nonlinear system here, and it's let's write them out more formally here. So that's negative 3, comma 3. Okay, so x could be negative 3 and y could be positive 3, or we could have the other way around. X could be positive 3 and y is negative 3. Okay, so what we saw here was that a technique that we can normally apply to linear equations actually did help us out a little bit for a nonlinear system of equations, and we had to do something that's a little bit different. You know, we had to simplify this and factor it and then take a square root of both sides. For linear equations, we generally don't really have to do that because everything's linear. There's really nothing to factor, right? But the point is that some of the techniques that we can apply to linear systems may actually work for nonlinear systems as well. So just something to keep an eye out for. So this has been an example of solving a nonlinear system, and I hope you found it helpful, and thank you for watching.